just so everybody knows, we are just done with that trig mini unit, the chapter 10 stuff. There's going to be no quiz, no test. That was just to kind of get you guys, a little bit of a space filler, a little bit of a get you ready for pre-calc, but not going to do whole lot more with it. Chapter 8 and chapter 9, which is probably take us to the end, will be covered more like actual units, and that they'll end in a test. So section 8.1, which is what we're doing today, is about variation. It's kind of disconnected from the rest of them in a sense. So the 8.3 through 8, I think we go through 8.5 is more connected, but this kind of gets us thinking about some of the types of functions or relations we'll be looking at. All right, so on that note, enough with the introduction. We will go ahead and get to it. All right, so today's notes are titled Variation. Okay, so in section A up there at the top of the front page, we're going to be looking at direct variation, also known as, these are just proportional lines. Okay. So two kind of things that are important there. Uh-oh, that's not what I wanted. I guess I pulled up my crayon, and of course it's not going to work. I just have not found my groove with my new setup yet. I'll get there eventually, I guess. This is what I was trying to highlight. Okay, those two things right there. All right, so anyways, in example 1, we want to know, do the following represent direct variation? If so, basically find K and then write the equation. All right, so for direct variation on those that I just highlighted, this is kind of the second one is the one we use to identify, right? So you just do y divided by x. And if that's constant the whole way through, then that table shows direct variation. In other words, that table has a proportional relationship. All right, so looking at A, if we do y divided by x, we'd have 2 over 1. That's equal to 2. 6 over 3 is also equal to 2, and 8 over 4 is also equal to 2. Since those are all equal to 2, the answer is that, yes, this is direct variation. We would say that K equals 2. K is the same as your slope, all right? That's K stands for constant of variation, also known as the slope of the line. And then the form of our equation is y equals K times x. So that would just be y equals 2x. And anytime you write an equation like that, you can always check to see if it really works, right? So if I do 2 times 1, I get 2. If I do 2 times 3, I get 6. If I do 2 times 4, I get 8, right? So, and then you can have one like B where it might be obvious, but that would be a no. Okay, that would be a no because if we did 4 over 1, that would not be the same thing as 8 over 3, right? So don't need to worry about the 4 and the 11 after that. Okay, so that's direct variation. You've seen that before. That's just a proportional line. Okay, and the way we check is to look at y over x. All right, and then inverse variation. This is going to be a little more new. Okay, so the important stuff about that is right here. Okay, so on that one, it's not y equals k times x. It's y equals k divided by x. So on that one, you actually have a variable in the denominator. So that's going to look a little bit different. And the way we check to see if it's direct variation is by using that. So here we do, if x times y is equal to the same thing the whole way through, it's called inverse variation. All right. So let's do a couple together, and then I'll have you guys try a couple. All right. So looking at example 2 there. So we do 20, sorry, I'm pulling out my pen. 20 times 1, we know that's 20. 10 times 2, that's also 20, so we keep going. 5 times 4, also 20. And then 4 times 5. So they're all equal to 20, all right? So this would be an example of inverse variation. All right, and it says k is equal to x times y, so k is equal to 20. And then we use this to write our rule. Y equals k over x. So y equals 20 over x. And then you would add that x cannot be equal to 0. Because we can't divide by 0. Okay? All right, and again, you can see that it works because, if I do 20 divided by 1, I get 20. 20 divided by 2, I get 10, and so on and so forth, right? All right, so let's look at C. I'm going to skip B and leave that for you guys. Look at C, and all we're actually, so it does ask for either. All right, it says, is it direct or is it inverse? So I skipped the direct part. So looking at C, just in general, as x increases, it looks like y decreases. So that cannot be direct variation. But if you wanted to check, you just do 12 over 1 is 12. 4 over 2 is 2. Those aren't the same, right? So then we go into multiplying. All right, so we try 12 times 1. Is that equal to 4 times 2? The answer is no, right? Even though it's equal to 3 times 4 and 6 times 2, the 4 times 2 throws it off. All right, so this would be an example of it's not direct variation because we talked about the division. It's not inverse. I might want to show that, I guess, because 12 over 1 is not equal to 4 over 2. So this would be neither. All right, so you guys try B and C, and I'll call on you here in about 2 minutes to make sure you have it. Is it direct? Is it inverse? Is it neither? If anybody has any questions or needs any help, you can let me know. Or feel free to talk to people around you. Compare answers at least. How about that game the other night? That was special. How about our boy Johnny? Just killing it. Looking like the second coming of Michael Jordan or something. Sheesh. But he wasn't in that top 10, so he didn't get that Coach Cal treatment, did he? Not that I'm bitter about that. Not that I'm bitter. All right, let's see. Ms. Rogers, were you able to get anywhere on B? Madeline Rogers? I guess that's a no. What about Patrick? You get anywhere on example B here? calling on all my virtual people here. Caroline Hadley, did you get anywhere on B?
I said it was direct variation.
Direct variation. All right. That looks good to me. So if we do 10 over 5, that's equal to 20 over 10, and that's equal to 30 over 15, and that's equal to 40 over 20, because they're all equal to 2. So then, Caroline, what would my equation be at the end? Y equals what? Or anybody? Can anybody help with that? What would it be? Y equals what? 2x. All right, so again, look at the difference between A and B, right? On A, as x increases, y decreases, right? So that can't be direct variation. On B, as x increases, y increases, right? So that's where you'd be looking for direct variation. Okay, so that's how you can kind of know number sense wise what you'd be looking for. All right, and then example D, Caitlin, were you able to get that far? It is neither, right? So so again, if you do if you check 40, well, let's just use that generalization I just said. We're looking at the table as x increases, y decreases. So you know you'd be looking for inverse only, right? So you're thinking, your thought process would go, let's do 40 times 0.5 and compare that to 12 times 1.2. And those aren't the same. So then, it's got to be neither at that point, right? Does that make sense? Does anybody have any questions on identifying direct or inverse variation? All right. Okay. So now looking at example 3, this is really the one that kind of has a little bit of tie-in to what we do the rest of the chapter. So it's on the back side, and this is where we're going to kind of use our graphing calculator. One thing I want you guys to do, and I'm not sure why I gave you this kind of graph, but let's at least make it somewhat usable, and let's scale it by let's count by 2s instead of 1s. I don't know if you want to mark out every number, but I'll just mark out a couple. So I'll say this is 2, this is 12, this is 2, this is 12, and then we'll just, I guess we could mark out the rest of them so it's not confusing. And then the same thing going the other way. The -2 out to -12. All right, so sorry about that, but that's going to make it just a little bit more usable for what we need. All right, so skipping ahead a little bit. All right, so what it says is suppose x and y vary inversely. All right, so immediately we think about, we have y equals k over x. And also k equals x times y. All right, so part A, write a function that models the inverse variation. All right, so they give me x and y. All right, so the first thing we would do is find, given x and y, find k. So we go k is equal to 8 times 6, or 48. So then we jump to this guy, and y equals k over x. That's going to be my equation. Y equals 48 over x. All right, so at that point, I'm going to try to graph this, I'm going to, instead of making like an XY table, okay, one more thing too. Let's say where x cannot be 0. Don't forget that part. All right, so instead of making an XY chart, we're going to use our graphing calculator. Y equals k over x. Or sorry, y equals 48 over x. So I'm going to go to y equals, I always forget to and it's 48 over x, so just 48 divided by x. And you could look at the screen. Actually, yeah, let's look at the graph. All right, so you kind of see, what looks like kind of just a two-part graph. It's actually a reflection of itself across that diagonal line. Y equals negative x. Okay. So anyways, let's go ahead and look at some points. All right, so I'm going to go to second graph to get to the table and just look to see, are there some points that I could use. So negative 148 is off my graph, negative 224 is off my graph. So let's use like these right here. So let's use negative 8, negative 6, negative 6, negative 8, and negative 4, negative 12. So we said negative 4 goes to negative 12. Negative 6 goes to negative 2, 4, 8. Sorry, I kind of made a stray mark there. And negative 8, 1, 2, 3, 4 goes to negative 6. All right, so that kind of gives us the shape of that curve. And then you're basically going to have the same thing on the other side. So you're going to have that positive 4 goes to positive 12. Positive 6 goes to positive 8. 1, 2, 3. Well, I keep trying to count and making these stray marks. And then positive 8 goes to positive 6. And then we said x can't be 0, so that's going to end up, if we zoomed way out on our graph, that x equals 0 line is going to be end up being what we call, and does anybody remember what that imaginary line that our graph can't cross is called? One of my favorite math words, starts with an A. Asymptote, right? So yeah, that's going to end up being an asymptote, which we're going to talk a lot about those, but just kind of throwing that out there. So yeah, that's kind of what one of these graphs looks like. So nothing like a direct variation, which is just a proportional line. This is something totally different. Anytime you throw a variable in the denominator, that's where it gets to a different kind of looking graph that we've never really seen before. Okay. So that's the last thing we're really going to need that for. And then part C wants to know, what's the value of x when y equals 10, or sorry, y when x equals 10, so we just sub in 48 over 10, just be 4.8. All right, so anyways, let's go ahead and keep it moving unless anybody has any questions. All right, before we do this next one, the table doesn't really work as is, so let's change this last entry to, instead of 14 and 16, let's change it to 15 and 15, because it doesn't really work with 14 and 16. All right, so it says, after a major storm, your math class volunteers to remove debris from yards. The table shows the time, T, in minutes that it takes a group of N students to remove the debris from an average size yard, right? So as N increases, T decreases, which makes sense because the more people we have cleaning up, the less time it's going to take to do said cleaning. All right, so looking at A, what function models this, right? So again, we just said if input increases, output decreases, we're thinking inverse, not direct variation, right? So let's go ahead and just find what our constant is, what K is. So that's going to be 225 over 1, or, sorry, 225 times 1, or 75 times 3, or 45 times 5, or 15 times 15. They all equal 225. So then I know instead of y, we're going to use t. So we'll say t equals 225. That's my constant over x. What's normally x in this case is called n. So t equals 225 over n. Our restriction would be that n can't be 0. Because if we had 0 students, it would take infinitely long to clean the yard, right? So anyways, part B says, how many students should there be to clear debris from an average size yard in at most 25 minutes? So when you set this one up, try to use, instead of an equal sign, try to use a, that'd be less than or equal to 25 minutes. All right, so I'm going to let you guys look at this for a minute. Actually, let's just do it together. All right, yeah, and then I'll let you guys try on the next one. All right. Well, does anybody think they know what the answer is before we get to it? Has anybody figured it out yet? Well, you guys work. That's all right. All right, so let's go ahead and just plug in 25. We'll use this and we'll plug in 25 for t. Okay, so we'd have t, and we want that. Sorry, we'll have 25 for t. So 25 needs to be less than or equal to 225 over n. All right, so then we'll try to solve for n. So we probably multiply both sides by n first. Then we can divide both sides by 25. All right, I have n. I think I wrote the inequality symbol backwards there. It should be n is greater than or equal to 9, because more students would mean less time. So let me flip that around. Sorry about that. All right, so we need at the end of the day, we would need at least 9 students if we want to clean it up in 25 or fewer minutes. We'd need at least 9. All right, so any questions on that one? Okay. Next problem, they're going to give you on MathXL, this would either say each pair is direct or inverse. This one says inverse variation, find the missing value. Okay, so here's how I do these. I take the given. If it's direct variation, you could just set up a simple proportion. That'd be the easiest way to do it, but it's not. So what I do here is I find k first. K equals x times y or y times x. So k equals 10. Now that we know that, we use y equals k over x to answer the next part. All right, so y equals k is 10, x is 4. So then you just work out what that is. 10 divided by 4 is going to be 2.5. And then you can just check to see if it works. If they're inverse variation, then both ordered pairs should multiply to the same thing. 2 times 5 is 10. 4 times 2.5 is 10. So you're good. Okay. So let me have you try the next one. It's also inverse variation. So you find the missing value. Feel free to compare answers with your neighbor. And we'll just do answer only on this. And we're kind of low on time, so if anybody's pretty sure they have the answer. X equals 8 is correct. That's correct. Now, you could probably use mental math, right? You know 4 times 6 is 24, so then you could just think what times 3 is 24. That's probably the easiest way to do it, really. But if the numbers are bigger or they're decimals or something, at least you have a step-by-step process. All right, now the last one is a little bit confusing, I think, these joint variations. So you'll probably have some questions on that when we get to the study guide, if there's anything from this lesson that you struggle with. But let's go ahead and look through this, and then we'll be finished. All right, so last example says write the function that models the variation, and then so we'll do that last. This will be step 2. So step 1 will be we're going to write the function that models this. So it says z varies jointly with x and y, right? So I'm just going to take this formula right from here. All right, so it says z equals k times x times y. Then we can sub in what we have and then solve for the missing variable. All right, so we'd have 60 equals k times 2 times 3. So just divide both sides by 6 to get 10 equals k. Now that we have that, then we go back to our original form there, and we'd have z equals k times x times y. So 10 times 4 times 9, which is 360. Like I said, those joint variations are a little bit tough, but you won't really get it after that one example. But you got a table there. If you get to one on MathXL, you don't really know how to do. All right, so sorry about taking the whole class. I'm going to try to do better. You got about 5 minutes. I'll leave it up to you whether you just want to hang out. That's probably all you have time to do. I will post the assignment for you. I think it's 8 questions, but I'll also post the recording of this video later.